Hi, welcome to Digital Electronic. I'm going to continue the next work on D flip flop. So D flip flop is almost same with the D latch. The only thing is in the flip flop you're going to have a clock instead of a normal changes. So this is actually is also known as a delay flip flop, and you are is used in data synchronization. So sometimes when you have a signal like this, and when you've been transferred to another place, sometimes there is a delay of receive. So maybe your data should be like this, but you receive a delay. So over here you are doing some correction so that it doesn't delay that much, or that it behave we understood the delay how much. So D will be your data, and you're going to have a clock. So the only thing is going to have over here is this. So when this triggered, D is transferred in the form. So you're going to have like in this particular, so you're going to have 0 and 1. So you're going to the changes only happen during the clock, and whatever you have, you're going to have a bit over here. So this is when when D is 1, when D is 1, uh, and your so because D is 1, this become 1, this is become 0, so this will be set. When D is 0, this will become 0, this become 1, this will become clear. Okay, so when you have a 0, you will become a clear. So you can always refer to the truth table. So this is how it looks in the time diagram. So first thing, always the clock. So please make sure the clock. For D flip-flop, usually we don't consider about the pre and clear, but sometimes they also encountered. But for the D flip-flop, usually only on focus on the data. So here, so there is a change, a delay. Let's say over here, your data 1 is respond for the Q1. So over here is 0, so you're going to have a 0. Okay, there is a change in the middle. Okay, let's say you have a change over here, but it's supposed to be not changed because you have to depends on the second cycle. So your second cycle is here, so that's why you're going to have here 1. Over here is 0, sorry, over here is 1, so you just follow 1. Over here is 0, so drop. Over here is 1, 1. Over here is 1, 1. Over here is 0, drop. 0, drop. 1. Here is 1, 1. Over here is 0, so it drop. So this is how it looks for this situation. Okay, so for this similar, so I think I will leave it this for you to do on your own. So please, the only thing is disadvantage in this particular. Let's say you have a response change in the same cycle. For example, like this, suddenly it dropped from 0 1, but you have 1 again. So over here, this particular will never been checked at all. Never been recognized at all. So refresh, we already go through the knowledge. So this is memorize this one. Knowledge, you have to memorize this one. So please careful. For knowledge, 0 0 is invalid. For knowledge, 1 1 is invalid. So you can remember this one. So try to remember also knowledge as other input, for because it's very important for SC flip flop and JK flip flop. D latch, so the advantage of D latch is when enable is 1, is going to be the result will be the same. but when there is zero, so it will be hold position. So this is the drawing. So this one and this one, be careful. For no latch, Q bar is at top. For non latch, Q bar is bottom, and this is how it looks for the latch. So for SE flip flop, so you're going to have a positive and negative. So you're going to have a whole clear set and also invalid. And for the JK flip flop, you have a positive, negative, and 1 1 is focusing on toggle. So yeah, there is. So this is the propagation, how characterization. So this one is discussing about the clock and also how it propagate. So you can have a look. So this is how the 50% and 40%. This is the decision making when you need to make a decision. Either you want to make it over here or over here. So this one is actually is very small number, maybe 1 millisecond, and you need to make a decision at 50% or 25%. You can set the thing later on. So, but we usually fix at 50% to make it easier. So this is the thing. So for those who are interested to know it more detail, especially during the computer architecture, you need to analyze, you need to know about this. So this particular situation actually will cause you some glitch. So I think I will check whether we going. So this is whole time. Uh, oh yeah. So this one is oh, okay. Okay, I don't have this one. Usually what happen is glitch is during sometimes we have a change like this, and this time when you have a change, uh, so if you magnify this one, usually this will happen like this, and another sim like this. So this 50% and this 50%, they have a time. So using this during the time, the small usually they have a glitch we call a small change, incomplete change, uh, incomplete change. So you can read out this one everything. Okay, another important is your frequency divider. Frequency divider can be done with your flip flop, especially JK flip flop. So the only thing is you need to make sure your pre and clear is connected to 1, and also J and K is always 1, because your truth table for JK flip-flop 1 1 is toggle. So we're going to use this one as our key. So J, K and K is 1. You're going to connect J and K 1. So this one we call flip-flop 1, flip-flop 2, flip-flop 3, flip-flop 4. So J and K is always 1. So the thing is you need to do the frequency. So let's say you have a frequency. So there is a this one is called 4 stage. So the this is the clock. So this particular clock is going in and is going to be processed. So the output as the Q is always changed on the cycle base. So if you see over here, so at this particular cycle, there is the Q bar, QA will have a response change. Over here, there is no change. You will wait for the next cycle. So you have this one, 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 and this one. So it's always depend on this particular response. For the next cycle, so this is rising, 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 this is rising. So your response will depend on the rising part. So this is rising, this is not, this is change, toggle, 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 this one. So next step will be your this, this, this. That's why for the SC will have this one, will have this one, and the next one will have uh, a response of here and also here. So that's why you're going to have a very big um, response until toggle over here. So for the QA, so let's say your clock frequency is 100, so this is 100 hertz. So for the Q bar is always divide by 2, so 100 divided by 2 is 50. So this is 100 hertz, this is 50 hertz. For this one, if you see over here, you have 1 2 3 4 5 6 7 8 9 10 11. So you're going to have, you divide by 2, you're going to have 1 2 3 4 5 6. You have a 6 over here, and now you are changing another half of it, 6 to become 3, 1 2 3. So this one is 50. 50 divided by 2 is 25 hertz. 25 hertz divided by 2, you're going to have 12.5 hertz, and 12.5 hertz divided by 2 will have 6.25 hertz. So that's why we call it voltage divider. So you always divide by your clock, divide by 2 for each flip-flop. Right, this is important, you can have a look. This is one shot, so you just have read this one, just read it to increase your understanding. Okay, this is a asynchronous counter. Asynchronous counter is to count from 0 to 16. So you have a study on this particular, so you're going to have a clock going in, JK flip-flop, so you can use the same. This is the situation. So Jake, I think I will cover this later on again. So you're going to have so you can have a look over here. So this one becomes 0000, 0001, 0010, 0011, 0100. So you can see the decimal increasing until 1111, and then it become here become 00 again. So this one we call from 0 to 15, we call 16 mode counter. So it will highly depend how many flip-flop are you using. So for flip-flop, the maximum is 15. So this is a summary. uh, so if you want to have a look, you also can have a look mode 10. So there is will be some modification they will make to make it to calculate until mode 10 only. So that's all. I think I have covered everything that you need. Right, thank you.